Hey everyone, welcome back to my channel. So this video, we're gonna implement queue using stacks. As prerequisites, I assume that you have been watched my previous video 225, where we implement the stacks using queue. So in that video, I introduced what is stack and what is queue in detail. So if you didn't know what the queue or stack is, you can watch that video before this video. So basically, we will use the stack, which is a LIFO data structure, to implement the queue, which is the FIFO structure, and implement some basic functions, push, pop, pick, and empty. So we have two stacks. Say we have a data set 1, 2, and 3. So for first step, if we want to push two elements, so the first one will be pushed to the bottom of the stack, and the 2 will be on top of the stack. So at this time, if we want to pop the element of the queue, how are we going to do this? If we just have one stack and call the pop function, we will just pop out the 2, which is on the top of the stack. But we're going to implement the queue class, right? So we want to pop the element that's getting into the stack first. So it should be the 1. So we have two stacks. So every time we want to pop out in the same behavior as the queue, we first will pop out every element in the first stack to the second stack. So 2 will be pop up first, and then the 1. So 1 will be the top element of the second stack. And then we can just use the like S2 at the index -1 to access the most recently added element of the stack to implement the same behavior as the queue. So after pop out the element, if we want to push more elements, how are we going to do this? So we simply just push the new element continuously to the first stack. So at this time, if we want to pop out, how are we going to do this? Should we just move all the elements in the first stack to the second one? So think about this. If we do that, we will move the 3, right, and append it into the second stack. It will be this. And the element that popped out will be 3. But since we are queue, right, so we want to pop out the earliest element that get into the queue. So that should be the 2, right? So instead of adding the 3 into the second stack, we will check if the second stack is empty. If it's not empty, it means that there are still some elements that get into the queue earlier than the 3. So we will pop out the element in the second stack instead of adding the 3 into the second stack. And we will pop out the 2. At this time, if we push another element like 4 into the first stack and call the pop function another time, how are we going to do this? So since the stack 2 is empty, so there are no more elements that come into the queue earlier than the element in the stack 1. So we will do the same process as we do in the first step. We will just move every element in the stack 1 to the stack 2. So that would be 4 and 3. And stack 1 will be empty. So at this time, 3 is the earliest element getting into the queue. So it will be pop out. So let's see how we're going to do this in code. Now let's code the stuff. So as we said in previous part, we need 2 stacks to implement the queue. Since we didn't have the stack library in Python, we will use the list to have the same effect. So for the push, it's literally just append element into the first stack. So pop function is the most important one. So remember how we're going to do this? So initially, there were no element in the stack 2. So we will move every element in the first stack into the second stack and pop out the most recently added elements. So this condition ensures that we visited every element in the stack 1. We will pop out every element in the stack 1 and append them into the second stack. And then we will just return the most recently added element of the second stack. So how we're going to do this is to access the stack 2 at the -1. So remember, if there have been some elements in the stack 2, we need to pop out them first, right? So we need to check if the stack 2 is empty. If not empty, we will just moving every element to the stack 2. If there was some elements in the stack 2, we need to pop out them first. So for the peek, it's basically the same process as the pop, but we don't actually pop out the element, we just return the value. So for empty, because both elements could have elements, we need to check both of them. But a slightly clever way is to check the max length of these two stacks. If the maximum length of the stack is 0, it means that all of them are empty. Okay, let's see how it works. So there is a typo here. For pop out, we cannot do both things to access and pop. So we'll just do the pop. Also, because the return type is Boolean, we cannot just return the max integer value. We need to check if it's 0. Okay, so it's an efficient algorithm to solve this problem.